All right, good afternoon. We are on section 6.3, proportions. Go ahead and hit pause and write these notes down. So go ahead and do that first. All right, we're talking about proportions, and they are equations stating that two ratios or rates are equal. Proportional is if the two quantities have a constant ratio or rate. So when we talk about proportions, one way is thinking of something that's outside of math related. Possibly looking at someone's face, your actual face itself having two eyes, two ears, you have a nose with the two nostrils on both sides, and if you're to cut your mouth down the middle, you've got the equal side on both sides. You got the two arms, two legs, and so forth. So your body in general is proportional. Another way of looking at it is when you draw a tree or think of going out to purchase a Christmas tree. One way of doing that is that line of symmetry, the line that cuts it down the middle. You can see that it's equal on both sides. It's that perfect tree that you're looking for, which if you're looking for that perfect tree, you probably need to buy an artificial tree. But that is, again, proportional. Now, when you are looking at these particular problems, these are two, again, ratios or written as fractions. If you're to divide or reduce by 2, you get 10 prints costing $2. Well, it's the same thing as if we reduce that by 2 and find that unit rate by dividing by 2, you get 5 prints for $1. You can also look at it the other direction as to where we have 5 prints to $2. And maybe we want to buy 30 prints. So how much would that cost? Well, since 5 can go into 30 6 times, we multiply both the numerator and denominator by 6, and that gives you then 12. So it'd be $12 for that 30 prints. Let's go ahead and look at the next problem. And this is virtually what you're doing today. It says determine if the quantities in each pair of rates are proportional. Explain your reasoning. You're going to use cross multiplication to solve. So we have 20 miles in 5 hours, separated by a colon or semicolon, which then is 45 miles in 9 hours. Well, using cross multiplication to solve, first of all, we have to write these as a ratio. And again, you're writing them in the same order that's given, working left to right. First number you read is the first number you write on top as your numerator over your denominator. Doesn't matter if it's proper or improper fraction. Remember, you're just comparing these two numbers or situations. And then you would do the same for the other part. Now, using cross multiplication, or we also sometimes call it cross product, you multiply diagonally. So you look at your diagonal numbers just like you would diagonally for reducing, but today you're not reducing, you are multiplying. So 5 times 45, which we have here, and then 20 times 9, which is here, and we get 225 equals 180. Does it equal each other? It does not. So you simply draw a line through the equal sign, meaning not equal. Okay, and you might have to do some work off to the side as well, so certainly do that. We will also allow you today to use calculators. So if a calculator is something that you have, you certainly are welcome to do that actually from here on out through the course of the year. So let's look at our next problem. And I want you to go ahead and hit pause, and you can then solve this. So go ahead and do that. So my first fraction is going to be $24 over 3 weeks. We're going to assume that it equals $52 over 7 weeks. Okay, now we can cross multiply, and it would be 3 times 52 equals 24 times 7. Now again, you could have put the 24 times 7 over here and the 3 times 52 on the other side. It does not matter. Then we take this, and we're going to see that when we multiply, we get 156 equals, and then this side, when we multiply, you get 168. Are those two numbers equal? No, they are not. Therefore, not equal would be your answer. All of what you see here is what you will need to have on your homework paper, so make certain that you do that. Let's look at our next problem. Go ahead and hit pause and solve this. So we have 270 over 3, and then 450 over 5. Now we're going to use cross multiplication to solve. So 270 times 5 equals 450 times 3. And when we multiply these together, we do get 1,350 equals, and this side is 1,350. Therefore, they are equal since they are the same number. And again, all of what you see here is what needs to be written on your paper today. Let's take a look at our last problem. Go ahead and hit pause and solve this. So we have 16 breaths over 60 minutes equals 14 breaths over 15 seconds. Now the issue that we ran into is that we are looking at minutes and seconds. In order for these two to be equal, we must have the same unit of measurement for numerators, which we do, and denominators, which we do not. So in order to make this happen and make them equivalent with units of measurement, we have to then multiply, or I should say make equivalent to minutes or to seconds. Now I will say, usually getting your answer to become the smaller unit of measurement is usually much easier. Because if we didn't in this case and tried to make this minutes, this would be a decimal point. Okay? And I don't think we want to go down that path. I think it's a little easier if we make the minutes into seconds. And if we recall, how many seconds are in 1 minute? Well, 60 seconds equals 1 minute. Since that's the case, if I have 60 of those minutes, then I've got to multiply this by 60 to get the seconds. But I can't only multiply this, I also have to multiply the numerator. So now, with cross product, or actually I'm going to get this set up first, and when I multiply this together, I get 60 times 60, which is 3,600, and then 60 times 16 is going to give me 36,006, which gives me 960, equals 14 over 15. Okay, now, and this is B, I can take that off of there. And so now, cross multiply. So go ahead and do that. And when you do, 3,600 times 14 equals 960 times 15. And I know that this answer right here is 50,400 equals, and then 960 times 15 is 14,400, and therefore these two are not equal. So there's a lot involved with this particular problem. There's not a lot on homework that do this, but you do need to pay attention to make certain that these denominators are the same unit of measurement. If they are not, you must make them the same unit of measurement, And that one equation or that one ratio that you change, you got to do it to both. Okay? So make certain that you do that. Have a great day, and we will see you tomorrow.